why don't we go ahead and get started? So just to introduce myself, for those of you that don't know me, my name is Dave Eckroat. I am the VP of Sales and Operations for IDEA StatiCa US. With me today is Andrea Castello, our technical manager for the US market. And obviously we're going to be talking about anchor reinforcement in baseplate design. This is obviously something that was of interest to everyone. We did break our own record for most registrants. We're just over 1,100 registrants today, so I'm assuming we're going to be getting some good questions, and hopefully everybody finds this very helpful. So next slide. Just as a reminder, I'm sure most of you have used GoToWebinar before, but if you have any questions, you can just type those right in the control panel. There's a questions tab, so you can send those over as well. Also, there is a PDF of the presentation that we're going to be going through that's downloadable for you. Next. So just to kind of go over an agenda, first thing is just kind of an introduction to IDEA StatiCa. I know we have a lot of our users on, but we also are going to have some people that are completely new to IDEA StatiCa. So just a brief introduction of us and the company. Then we're going to review some of the version 25 highlights. So version 25 was released last week. So we're about a week into it. And that includes what we're going to be covering here today, which is kind of the entire workflow, complete workflow for baseplate design and anchor reinforcement. So basically from the baseplate through reinforced concrete design in the foundations. Then we'll review kind of some next steps as far as where you can find additional information and how you can start to work with this workflow. We'll also mention that we're doing a Texas Roadshow in the next couple weeks. And then finally, we'll do some Q&A. So next slide. Okay, so IDEA StatiCa, obviously we're a structural engineering software company. We go a different route than most of the providers in that we are focused on structural details. We don't have a general purpose program. We aren't planning on doing any kind of general purpose. We're really looking at supplementing other main software, but to allow you to do details. So just kind of going through our offerings for the US market. So we have Connection, which is part of our steel package. That's what probably most of you have heard of us before. So really can do any steel connection from the most simple to the most complex within the software. We do have links to all the main analysis tools as well as the detailing tools for Connection. Included with Connection in our steel package is Member. So this is really a specialty tool to kind of be able to evaluate your critical members, primarily focused on lateral torsional buckling. This would be kind of beyond what you would typically do with your general purpose software. And the thing that makes it, that differentiates it, is that you're able to model the end connections and take that stiffness into consideration in that buckling analysis. So really a kind of unique tool that could be very helpful. I know we actually have some people that have been using it, have some case studies and some different use cases now on the website. Something that's relatively new is Detail. So this is a concrete solution. It's really meant for discontinuous regions in concrete members. Think of an alternative to strut and tie method. I know how much everyone loves to do strut and tie by hand. So this gives you an option to use finite element to look at those designs. So whether it be openings in walls, haunches, depth ends, walking columns, that's what Detail would be used for. And then finally, we're going to talk about this integration that we have. So Connection and Detail. So this is, again, the complete workflow for baseplate design, including the reinforced concrete below the steel. So that's really what we're going to be talking about for the rest of today. So next slide. So when we start to look at version 25 from the steel standpoint, first thing you're going to notice when you download it and open it up is that the launcher's definitely going to look different. We've kind of updated things. You still have all of your previous files there, but we also have a news section that's expanded. So this way we can kind of push out information as far as for webinars, other things that we want to kind of promote to our user base. Also, from right there, you also have the ability to use a lot of our resources. So whether it be getting to tutorials or webinars, knowledge base articles, you're able to kind of click on those individual boxes that you can see there at the top. You might not be able to see it, it might be kind of small on your screen, but you have those resources right from the launcher, so you don't have to necessarily go into a web, kind of a browser to kind of find those things. As well as the fact that our e-learning, our campus courses are listed below there. So this way, if you're new to the software and you want to start to try to do some self-paced learning, you're able to do it right from the launcher, and that'll just open up your browser window to take you to the right spot. The next thing you'll notice with Connection is that the wizard has been completely updated. It looks more, if any of you have used our web connection library, it's going to look very similar to that, where you choose your geometry. Then you can select your designs. The nice thing is that when you select your designs, you have some predefined templates there, but also if you already have saved in your personal or company sets, those connections will be right there, and you can start with that as a template. So I think this is very nice to kind of be able to help everyone use the information they already have and kind of build together in the software. The next highlight is slotted holes. So I know this was something we've had a lot of questions about as far as how to kind of be able to put the slots in specific elements of the connection. So this is now you're able to kind of choose whether you put the slots in the beam web, in the plates, flanges, wherever you need to put slots, you can put those in. One thing to note, I know this always kind of relates to oversized holes. Unfortunately, we still don't have oversized holes. I know that's a sticking point for a few of our users. We just have not figured out how to kind of have that modeled within our finite element model. So we're going to keep working on it though. The next thing that's going to be interesting that most of you aren't going to see or not going to, kind of, it's not really a big issue for especially the existing users, but we've kind of changed some of the phrasing within the software. So rather than being kind of Eurocentric, we now have, instead of a fin plate, you're going to see that it's going to be a shear plate, or instead of a cleat, a clip angle, CJP weld, not a butt weld. So we're just trying to kind of make it a little bit more user-friendly for our users. Another few options that we've gotten a lot of requests for with the anchor design, we have added AISC 318.19. So that should be a little bit more current. And then also another thing that we've just heard a lot about is being able to save custom materials and custom cross sections into the material properties library. So this way you do it once and it's saved into your software. You don't have to keep rebuilding the same materials or same cross sections going forward, especially if you use it all the time. So those are just a few of the highlights from Steel. We do have a link on that page to the full release notes, so you can always kind of jump into that. When we start to look at detail, so again, obviously the connection and detail integration, which we'll be going through here shortly, you're able to model embed plates. So that's another option that was very useful. And then finally, there's new templates for detail specifically for ACI code. So whether it be walking columns, coupling beams, piers, beams with openings, we have a bunch of new templates within the software to be able to use for concrete. And then the final thing is just that we're able to now put pre-stressing tendons into beam designs. So you're able to kind of do some pre-stressing of the concrete member within detail. So those are just some very quick highlights of version 25. Let's see. So now what I'm going to do is I'm going to launch a poll. I hope everybody could respond. So the poll is, how often do you have to design anchorage reinforcement on your projects? And just kind of giving it by percentage. Um, just want to kind of make sure. I mean, obviously, this is a topic that everyone is very interested in, just by the sheer turnout. Um, so we'll just give this a minute here to let everybody answer. Okay, give it another 10 seconds. Okay. So what I'm going to do is actually, let me just share those results. So pretty evenly distributed across the different answers that we had. So thank you for being involved in that. And from here, I am going to hand off to Andrea to discuss the baseplate workflow.
All right. Thank you, Dave. Okay, so let's start. Okay, let's start with the demonstration of this new workflow. To simplify this presentation, I summarized the process in 3 simple steps, all right? So from the connection application, we'll start modeling and design the base plate, including anchor checks using ACI code formulas. If your anchors are failing for concrete breakout, either tension or shear, ACI gives the option to utilize anchor reinforcement. And that is when you will need to design anchor reinforcement, and this is a time where our new integration with IDEA StatiCa Concrete solution comes into play. However, for instance, EORs also need to design the concrete pedestal, piers, or even the foundation. So the integration is not limited only when the anchors are failing for concrete breakout. The EOR can take advantage of the integration and design accurately the concrete below the base plate. Once you have the base plate and anchor designed, you can export the model geometry, all the elements, like the anchors or shear logs, and loads or load combinations to detail application. In detail application, you will need to model the reinforcement and run the analysis. Finally, you can review results and design or optimize the concrete reinforcement. Now let's jump into this live demonstration. To give you some background, this is the example I'm going to work on. I am going to design the base plate and pedestal for a column that's 12 by 40. So we have this pedestal section, and we determine that our standard vertical reinforcement to cover the minimum area of reinforcement is 0.5% of the area. So the reinforcement will be 6 bars of number 6 for this vertical reinforcement. Then we'll have 2 load combinations, which is compression plus moment plus shear force. And then the second combination is going to be tension force or uplift forces and shear forces, right? So let's jump into the software, into connection application. So this is connection application for those of you that haven't seen this. So this is my model. Here you can see the member 12 by 40. You can see all the details here. And then in connection application, we model connections through operations, and this is the base plate operation. You will see that you can define all the properties in this area, and then all the anchors details. Here I'm using 7/8 anchors, and then you can specify the length, the anchor type at the end, and then the welds. So you can define like all these properties in the model. Then you can define the foundation block, which is this concrete block. But remember that in IDEA StatiCa Connection, we consider this as an unreinforced concrete block, right? You can define the offsets. I mean, in this case, it's 2 inches from each side of the base plate, but you can input four offsets in this base plate, and then you'll have different distances from all other edges. So in this case, it's at the center point of this concrete block. And then you can define how to transfer the shear force. In this case, I selected shear log and define it at plate as a shear log, right? So you can see it down here. So we're basically modeling all the base plate elements into one operation. So you can control it from here. Later, you will see the load effects applied on this column, okay? So you can see that we have here compression forces, shear forces, plus moment forces, then uplift forces, shear forces, and that's it. So we have two load effects here. So let's hit calculate and run the analysis for this. And now we can see the summary of results. So we can see in this summary that the anchors are failing. But to really review the results, you go into the check tab, and we can look at the deformed shape. So we can look at how this model is being deformed for the different load combinations. So this is the first load combination, and you can see that we have some tension forces on these 2 anchors only, because it's we have a moment, right, going to this side, so it's pulling these 2 anchors. And if we look at the T plus B load effect, we can see that we have tension forces on the four anchors, right? So then if we jump into the anchors results, you will see that we have all the checks here. If we click over here, this will tell us what is the critical load effect for each anchor, right? And the tension forces on the anchor, so you can see them here, and utilization ratios. Then if we look into the plus icon, you will see the ACI calculations. In this new version, we're using ACI 318 2019 version, right? And then you can see, let me just right click over this calculation report, and you will see all the checks, all the code checks that we are doing for the anchors. Like in this case, you can see that the anchor itself is okay for the tension force that we have, or that we calculate in the analysis. However, if we scroll down here, we can see that the concrete breakout tension, concrete breakout resistance check for the anchor in tension is failing for the group of anchors, right? So you will see the sum of tension forces of anchors with common concrete breakout cone area, and this is the one that it's failing. So we scroll down and we can look at the different ACI formulas, right? So if we close this and then we check all of them, we'll see similar results. The concrete breakout resistance for tension, it's failing in the 4 anchors. Again, ACI allows you to use concrete reinforcement. I mean the concrete steel reinforcement in the concrete block to resist this concrete breakout. However, in IDEA StatiCa, this is an unreinforced concrete block. So what we'll do now, so the next step is to use this new icon that we have here, which is called RC check. That will export this model to detail application. So we'll click on that one. And I'm calling concrete pedestal check. So now we are in detail application. You will see it here. I mean, it has similar interface as connection. If you know connection and you're used to connection, this will be very similar to what you do in connection application. But now we are focusing on the concrete block, right? Now you can see that we imported the base plate, the anchors, and even the shear log, right? Then if we explore every item from here, you will see all the details coming from connection application. Then this is the concrete block entity or member, right? And you can modify the shape if you need it from here, okay? And then if you go into the support area, supports, so this surface support is created at the bottom part of this cube, let's say, so it's under surface 5, well, in surface 5, and you can see it here. So this is a way to fix some of the degrees of freedom of that surface. In this case, we have the compression only spring support active. For this situation where we're just focusing on the pedestal and this will continue to an isolated foundation, we can just turn it off, right? If this is a case where your concrete block is going to be set in the ground, then you can use this one here. But we are just focusing on the pedestal and that will be continuous. So I am supposing this is like totally fixed at this position, okay? So that's why I am unchecking this option. If you have the actual spring of the soil, you can change this user value of stiffness of the spring, and you can click over this icon and then add the value, okay? Now, if we jump into the transfer devices, which are the base plate, you will see the same details that you model in connection application. And also you can set up how to transfer the force. This is again imported from connection, right? So you don't have to worry about this. If we jump into the different anchors, you will see that here we have the anchor type. This is where you can change the type of anchor. If you have adhesive anchors, this is where you can change it, and then you can input your bond strength. But in this case, I will keep the casting place casting place anchors, let's say, right? And because we have washer plates, the perfect bond option was selected, okay? And then when we bring information or when we bring a model from connection, we need to have this on check, all right? And then if you hover the mouse over the different like inputs, you will see information here. Like this setting is valid only if the shear force transfer mechanism defined in the baseplate properties is set to anchors. If not, we will transfer everything through the shear log, all right? So this doesn't really matter at this point because it's at the shear log, right? So anyway, you will see also all the geometry set up here, and you will see similar things from this for all the 4 anchors in this model. If we jump into the load cases, you will see the forces on the base plate, right? And then the anchors. So these are the forces group, and you can even see the shape of that cross section that we have on this base plate, and then the forces on these anchors, which these are representing the tension forces. So that was what we were seeing on the C plus B plus M, and then the tension plus shear, we have tension forces in the 4 anchors here, all right? So no worries with that. Then here we have just the load combinations. So if you click over the over the pencil icon, you will see the factors of 1. So that's okay. So this model is almost ready, but you can see here a message that says non-conformity. So we don't have any reinforcement defined in the model, so we cannot run the analysis, okay? So now in this case, we need the reinforcement. So the way we add reinforcement to this model is by using this kind of operation, similar to operations in connection. So we have this group of bars, so we activate that, all right? And then we start setting up our rebar property. So first of all, I'm going to change this to a diameter of 6, and I'm going to start placing the vertical reinforcement. You can see in the concrete block that we have some numbers, some brackets. Those are representation of the surfaces. So if you scroll down here, also just starting to set up the surface. So the surface 1 is fine. And then the definition of the bar shape is only on surface H. So this is defined on H1. So you can see if you like kind of rotate this model, this is H1, right? So I'm going to place it on H4, right? So now it's rotating that rebar. Now we have, if we scroll up down here, we have number of bars in the layer. We have 2. Okay, so I'm going to define 3 of them in this layer, and there is only 1 layer. Okay, so you can place more layers in this operation, but I'll just use this 1 layer. And then if we look at the top view, here we have the 3 bars, and the distance between them is 6. So oops, let me go back to the model. The distance between the bars is going to be 9, okay? And so we have that. Now, as I mentioned, this is going to be a continuous structure, right? So at the end of this anchorage, or at the end of this reinforcement, this is going to be continuous. So you can set up the anchorage type at the end of this rebar. So that will continue through the model, okay? So this rebar is going to continue through it. And then I believe that's it. We set up those 3. Now I'm going to right click and copy this operation and copy on surface number 3. Okay. So we just changed the surface. Oops, 4 was fine. I changed the surface to 3, and now that will be copied on the other surface. Then let's start placing the stirrups. So I'm going to add a new rebar, group of bars here. And then I'm going to select surface 5. Oops, surface 5, right? And oh, there you go. In this case, is going to have also one bar in the layer. But instead of just having this in one edge, I'm going to use on surface edge on more edges. So I click over that, and then surface again is going to be 5, right? And now I can specify like what edges I want this bar to be like kind of continuous. So that will be 1, 2, 3, and 4. So I can come here, 1, 2, 3, and 4, right? And then the end, I can use a hook here and over here. So also let me decrease the size of this bar to be a number 4, right? And now let me change this to surface 6 because it's going to be from the top surface. And then I'm going to add three layers, and the distance between them will be 3 inches. That's for like kind of the top part. Then I'm going to copy this so I can change the distance between these layers. So now there will be 6 layers with a distance of 6 inches. I am going to use this surface cover to move that down like 12 inches. And actually, they are not 6 layers, they are 4 only. So now we have different like distances between the syrups for this like group in the bottom, right? So that's basically how you model this. I have the model ready here with the central, like the cross tie here. So you can see it's something similar. So I use surface edge, and then I use these hooks here, and basically you can just start playing with this inputs to locate your reinforcement, right? And then another important thing is that you can change the name of this group of bars. So later when you're reviewing the report, you will see the results for each group of bars. All right. So once you're okay with your reinforcement, this is our standard reinforcement, right? We're not looking at anchor reinforcement yet. So it's like, let's see how the standard reinforcement works, and after that you can start like optimizing your reinforcement. So then after that you start calculating your analysis. Okay, so here I have the model already with the analysis already finished. Okay. So in this case, the analysis is stopped. You can see all these messages here. So it's telling you basically that the calculation stopped because the criteria were exceeded, right? So this information over here, it's going to tell you at what percentage of the load combination it is stopped, right? This means it is stopping the analysis whenever something reached the limit. Like in this case, the anchorage reached the limit, but also you can see that the reinforcement did the same, right? The concrete was at 99.5%. So of course, we have this setting like to stop the analysis whenever something fails, because with that we can save some time. So then if now to check the results, we can go to the check tab, similar to what we do with connection application. And the first thing you will see is this summary of results. So we'll control the different results from this area, from this ribbon. And the first thing that we are looking at is this summary. So you will see these red lines representing the compression stresses on the concrete, and then the tension stresses are represented in the reinforcement, okay? Because that's how we are transferring the forces in this system. Through this steel reinforcement, we are transferring the tension forces, right? So here also you have the two load combinations. So you can click over this C plus B and plus M. So this will be the stress flow, as you can see here. That's what we have active here. And you will see how the stress, or the stresses were flowing through this system. But this, you can see that here we have the compression forces, shear forces, and moment forces. If you remember, we have two anchors in tension. So you can see that they are kind of pulling the concrete, and they are generating this kind of vectors, right? And then if you rotate this, see how the forces are being distributed to the steel reinforcement, to the vertical reinforcement. So that's how the anchors are distributing these forces. So you can almost see like the strut and tie methodology, like here in this model, right? That's how the design guides are recommending where to locate this anchor reinforcement. But here you can see it like graphically in this model. Then if you also look at this area, you will see it's not shown here, but the shear log was at this position, right? And the shear force is being transmitted through it. And you can almost see the concrete, like the concrete bearing, like the shear log bearing on the concrete, and how the compression forces goes into this side. Also, you can active the loads, so the stress flow will make more sense to you when you active these loads. Obviously, in this case, we have very simple kind of load combinations, but when you have more complicated model or load effects in the base plate, it's just better to draw the loads to see what's going on. Then if we change to the T plus B, right, again, the shear force was higher in this load combination, and you can see the concrete bearing like the bearing of the shear log on the concrete, right? So this is how the concrete or like this forces are being distributed to the other reinforcement in this model. Okay. And again, we can see these vectors at the bottom of the anchors, creating like kind of a compression forces in this part of the concrete because they are pulling up, right? Now, this is just the summary, but if we look at the strength, we can look at the strength results for concrete and then reinforcement. Here we'll see utilization ratios for the concrete. So we'll see the actual stress, the actual compressive stress versus the actual strength. So all the material, like the concrete material, is multiplied by a factor of 0.75, and that will be our limit. Okay, so that's how we get this. Then if we look at this FC, we'll see the compressive forces on the concrete as well, right? So you can change the different load combinations, and remember we have one portion of the structure pushing in this area. I mean, one part of the cross section pushing in this area of the concrete, right? So it's really clear. Then if we jump into the reinforcement, we are also looking at the utilization ratio. So it's drawing here the ratio of stress and the strength for the selected material. So that's one way to see it. You can see that these two are at 100% of kind of utilization. And then if we look at the stresses on the steel, so this is the stress in the reinforcement. You can see like for this combination, here we have some tension forces and then compression forces in the reinforcement, right? So it's pretty clear how this is behaving. And then here we have some 45 PSI, right? So this is on the elastic limit, which is 45. It's 60 PSI multiplied by 0.75. So this is the one that it's reaching the elastic range of that steel. All right. And so if we change the different like load combinations, you will see where is the critical reinforcement. So we have it here. So that's basically what it stopped the analysis, the capacity of the reinforcement, like the tension reinforcement on or the tension forces on the reinforcement, right? And then if we jump into the anchorage, we'll see the bond stresses as well, and also utilization ratio of the stresses. So this rebar is at 100%. So again, we are seeing here the stress check or the utilization ratio, and then we can change this to bond stress, right? So again, it's pretty clear that we have an issue on the bond stresses for the reinforcement, right? If we change to this utilization ratio in terms of anchorage and also in terms of the strength of the reinforcement, okay? So together with the utilization ratios and the stress flow, then you can determine what to do. Like in this case, we can look at this view here, and this anchor is transferring some forces to this reinforcement. The same here. So probably we can just play around with the reinforcement and add maybe a vertical rebar here, vertical rebar here, and see how this change. So that's what I did. If I go to the design tab, what I did is I copied this model and test out different reinforcement arrangements. So if I go to detail, to the second detail here, let's give it a second. All right, and then let's look at the design here. Let me draw the rebars. And in this case, I added two extra vertical bars in the sides, right? And then we can look at the results, it finish, and the utilization ratio is lower than 100% for all the checks, right? So again, it's pretty clear how this anchor is distributing. Also, now it's getting help from these two rebars here, these vertical bars. So let me change it to this one. And that's helping out a lot for this tension forces on the anchors, right? Again, for this demonstration, I decided to do only the pedestal. But if we have the whole thing, like the foundation, the isolated foundation as well, we can also review the development length and we'll look into the anchorage results to see if that is enough for that development length, right? And then in this detail tree, what I did is that instead of two rebars in this side, I just placed one. So I just wanted to see if that was also okay. So utilization ratios are under 100%. So, I mean, this is a very simple detail, right? Where you just have more vertical reinforcement. But remember that we can start extrapolating these models to a more complex design where you have a base plate with a bracing element, where you have a different shape of the concrete block, where you are in the near the edge of the foundation. So there are different cases where you can use this integration. All right. So let me go back to the presentation here. And the last part that I am going to show here about the software is that you will get this report. In the report, you will see things like the 3D view and model properties. Let me zoom in here in this report here, and you will see the properties of all the elements, the base plate, all the details, the distances of the anchors, right? Then in the second screen, I am showing, or the second page, I'm showing that we are showing the applied loads, the result summary, the stress flow. Then we can look at the different stress, reinforcement stress by groups. So that's why I was mentioning that this is important, right? To rename the operation, so you will see the stresses on each reinforcement. So that's useful. Then you can look at the code settings. Of course, we have this reduction factors for the strength of the concrete and reinforcement. We are using 0.75. You can change this if you need it, right? But this is the most conservative factor that we are using for the materials. But that's something you can modify. And bond stress by groups, similar to what we saw in this area. We're looking at the bond stresses, so that's related to the anchorage of the steel or the steel reinforcement, right? So this is what you can export from that analysis, and yeah, so that's the overall workflow that I wanted to share today with you. To wrap up, I just want to reiterate on the different use cases of this integration. For the demo, I use a simple example, but again, you can extrapolate the process to a more complex design. So you can see here there are multiple options available, like the pedestal with a foundation, base plate and corner locations, or even base plates on a strip foundation. So again, there is no limitation in terms of geometry for the foundation. Let's summarize the presentation. The IDEA StatiCa Complete base plate design workflow simplifies the process by reducing the time spent in different applications to design the steel and concrete part of the base plate. Also reduces the manual inputs, and there is no limitation in terms of structural geometry or loads. Finally, one of the key benefits of the detail application is a clear 3D visualization of the reinforcement model and stress flow, so users can better understand load paths and optimize the concrete reinforcement design. Right? Well, thank you for your attention, and let's continue with some messages that we have for you. All right, Dave, I'm going to hand up to you.
Sure, thank you. So some next steps. So obviously we have some links in the handout to sample projects. There's some blog posts, tutorials, theoretical background. So kind of more information as you want to kind of understand how this workflow can be used. One thing that we're doing is that we are allowing either if you're an existing user of our steel product or you don't have any of our software, you can use the link on the right side of the screen or the QR code. You can fill out a page there and we will give you access to the Detail app. So you can kind of test it out, play with it, kind of understand how it will benefit you and your projects. Next slide. So we wanted to mention we are doing a Texas Roadshow in the next couple weeks. So you can see the link there if you wanted to attend. You can see we're going to be in Houston next Wednesday. And then the following week, we're going to be both in Fort Worth and Dallas. So Jan Gigon, who's our senior regional engineer, along with Johan Lozado, one of our product engineers, will be in attendance, as well as another product engineer from our headquarters. So definitely, if you're in those areas, feel free to sign up and learn a little bit more about IDEA and meet some other users. And now we'll get into some Q&A. So I apologize if I know some of you had some audio issues there for a little while. Hopefully that was taken care of. If you did have the audio issue, we will be posting the recording here in the next couple days. So that'll be posted on our website as well as on our YouTube channel. So you can kind of be able to review it, maybe go over some specific areas again. So just looking at the questions, we have a lot of questions. So I'm going to try to summarize these as best as I can. Let's see. So I know one of the questions that kept coming up was we're obviously showing square, like a square pedestal. And the question was whether we can do circular cross sections. I believe we have a polygon option. So you're not necessarily going to be able to do a round section, but you can do multifaceted kind of approximation to get like a polygon.
Yeah, so I'm showing here on the screen, Dave. Can you see my screen?
Yes.
Okay, perfect. Yeah. So from the connection application, you can only do it square shape, right? But then here in Detail, you can change that, and then you can edit the shape of this concrete block and use kind of this coordinate, so you can approximate this circular concrete block, right? So that'll be the workaround for now.
Okay, perfect. Another topic that was had a bunch of questions was related to the shear lug and whether you can have biaxial shear lugs or other shapes. Can you explain kind of what the ability of with the shear lugs are?
Yeah, so let's see, there you go. Now you're seeing my screen in connection application. So one important thing, it's in connection application, you will do the design of all the steel part, let's say, and also like the anchors checks as well. And then when we are here in connection app in this baseplate operation, if you remember, I show you that you can select a shear log to transfer the shear force. And then you can modify this cross section for the shear log, and then you use this plus icon, right? And in this case, I use this like kind of rectangular shape, which is going to create a plate, as you will see it there. But also you can use like general roll sections, and then you can use our general steel cross section editor, and that's how you will do biaxial shape for the shear log. There is a sample project in the website where I model that, and you can download that and see how that was created, but it's possible. So basically you can create whatever shape of the shear log you want to input here, and then we'll check that shear log in Connection app. All right.
Thanks, Andrea. Let me see here. Another question I saw requested a couple times was whether we can export any of the details, kind of the reinforcement, out to drawings or Revit, which I don't believe we can do at this point, correct?
No, we cannot export this 3D. However, obviously it's coming because we need to share this information with maybe detailers. But the version, like the 2D version, like the concrete solution for the walking columns, the walls, and all that stuff that they share at the start, for that kind of part of detail, we can export to CAD drawing. For this 3D detail application, we cannot export the details from reinforcement. But yeah, that'll be coming soon.
Okay. I'm just trying to go through here. Let's see. I'm just trying to go through some questions. Do we have an option? I saw this question a couple of times. For the bar hooks, do we have a 135-degree hook option?
No, we have the 180 and then the 90 degree. Yeah, and that's the only thing we have. Yeah.
Okay,
I
so we
mean,
need to get that.
yeah, we need to input that. Yeah, we don't have it here.
Okay. Sorry, going through a bunch of. There were a lot of questions that came in right at the end, so I'm just trying to kind of go through that. So I know that there's one question here asking about specific post-installed adhesive anchors. So we don't necessarily have specific vendors with the anchors, but can you explain that a little bit?
Yeah, so basically here what you will do is you select the adhesive anchor and then change the diameter, input your own diameter, the material properties of that anchor, and then you will look for the bond strength that the provider is like sharing in their technical, let's say, website, and then you can input this information here in IDEA StatiCa, and then that's how you cover those anchors, right?
Yep. And actually, I just wanted to kind of clarify something about the 135-degree hook. Johan actually just pinged me. So actually, we do have a polygon option within the reinforcement too. So you can actually do that as a, so you can kind of create that on your own, but I think we should kind of get that added in as a standard option.
Here I'm showing it on the shape definition of the vertical rebar yeah, whatever group of rebar.
Okay. I know we're not going to get to all these questions, so I will just mention that we will be sending out an email. Like if you have a question, if a specific question, we will be getting back to you with those questions. Another one that I've seen a couple of times is whether you can have a grout layer underneath the base plate, and that would be done in the connection app. So when you're designing the base plate, you do have the ability to either leave a gap or have a grout layer below the base plate. Just trying to see.
I'm seeing here. Yeah, I'm seeing here one question like regarding the shape of this concrete block. You can modify this concrete block shape. That's possible here in detail application. And this is, I mean, the way we import this or recreate this concrete block is through the connection app. However, you can also come to detail application and start a model from, let's say, from scratch, right? And in that case, if you have 2 columns in one concrete block, that will be possible. Just because in IDEA StatiCa Connection, we can just, I mean, we can work with 2 columns probably. But yeah, I'll suggest if you have this very complex design, you can also use detail application in a standalone way. And for that, you will have kind of more freedom, because I see that someone was describing a very complex concrete block. So that's possible. Even we have some operations to do some cuts on the concrete block. So you will see that's possible. All right.
And we're getting close to our time here. One other question I saw multiple times is what happens if you have multiple column bases residing on a single concrete element? Can you transfer that into, or how would you do that design?
If there are multiple, I mean, if there are 2, I will start it from connection app with the 2 connections. And then the great thing of this integration is that you don't have to worry about the load effects, right? But if they are like multiple columns, my recommendation will be, okay, start the model from scratch in detailed 3D application. But in that case, you will need to bring the loads like manually. You need to input those manually. So yeah, there are different approaches, but we can look at different cases if you send us an email, and probably we can find a solution there.
All right. With that, we're just about at 1 o'clock on the East Coast. So again, I thank everyone for joining the webinar. Hopefully it was very helpful. Obviously, if you have questions, feel free to reach out to us, and we can definitely help you. And again, I know Andre just posted in the chat the link to be able to test the access for 3 weeks of the Detail program. So again, thank you very much. Hope you have a wonderful day, and we'll see you soon. Thank you.